So today we're going to start talking about 10e, the tangent function. It is a little bit different than sine and cosine, so we are going to do a couple of examples for it. And the basics of the tangent function are also on the back of this formula packet. So you guys have that, not formula packet, unit circle packet. Alright, does everybody get the title?
Oh yeah. Okay, never mind.
Okay. Alright, everyone get their stat box? So then we gotta talk about tangent for a second here. We know that tangent is sine divided by cosine. So when we divide something, there's this opportunity for our function to be undefined. So for what values of x is tangent undefined? Like, what would make this function impossible to happen? In other words, what can't we divide by? We cannot divide by 0. So when cosine of x equals 0, then we have tangent being undefined. So we can't really have that. So if we think about it, now if you look at your unit circle, or if you look at the notes you took yesterday, or if you look at the back of this, we can see that cosine equals 0 at pi over 2, and cosine also equals 0 at 3 pi over 2. And because this is a periodic function and it's going to keep repeating that shape, this is going to keep going as well. 5 pi over 2, 7 pi over 2, and so on. So what happens is that we're going to have vertical asymptotes at all of these values. And we did talk about when functions are undefined and vertical asymptotes in chapter 2 of this year when we talked about functions. So that's one thing that's going to be different about our function, is that tangent doesn't make a wave like cosine and sine, because I have all of these vertical asymptotes that, remember, the function will get really close to, won't actually touch. So what's going to happen is, like I said, at all of these, we're then going to have to draw dotted lines for vertical asymptotes, and then we'll fill in like the rest of it. So on the next screen, we'll take a look at all of the basics for the tangent function and how they're a little bit different. Some of them are a little bit different than sine and cosine. So one thing, we know that the function will equal 0 when sine equals 0, and sine equals 0 at 0, pi, and 2 pi. So you can see that here, 0, pi, 2 pi, that's where my function equals 0. So it's crossing the x-axis. And the period's a little bit different. The period is actually just pi, not 2 pi. So you get one full cycle, one full tangent curve in pi instead of 2 pi like it takes for sine and cosine. Now, we didn't talk a lot about range for sine and cosine, but what's the maximum for sine and cosine? What's the maximum for just normal sine and cosine? 1. And what's the minimum? Negative 1. So for sine and cosine, the range is in between -1 and 1. But we can see here that, like, we keep going up and we keep going down. So my range is actually all real numbers. So that's different than sine and cosine. Sine and cosine, the range is between -1 and 1. Now these vertical asymptotes start at pi over 2, but then every pi unit, there's another vertical asymptote. And so we use this letter K to represent the fact that every pi units, there's another vertical asymptote. So pi over 2 plus pi is 3 pi over 2. Plus pi, 5 pi over 2. So we have these vertical asymptotes. And if I subtract pi and go into the negatives, we've got more vertical asymptotes. So that's, I don't want you to get freaked out about this like K that's in there. It's just saying that every pi at another asymptote. I think I have this on another screen, but I think it's worth mentioning here that the principal axis is the same as sine and cosine because the principal axis is just at 0. And so do you see how like at the x-axis here at the 0, that's almost like a turning point? Like we start curving and then we start curving the other way. You guys see where I'm going with that? So what we will take a look at is the fact that we can graph these and it affects the A, B, C, and D very similar to sine. The thing that's a little bit different is that we know that A affects our amplitude, which for sine and cosine affects the maximum and minimum. The amplitude would just like make our function become like steeper if you have a big number or become like wider if you had a smaller number. We're not going to have a lot of change with that A, but just in case you do see it. So before we get to that, quick little stop at the stop box. How is a tangent function different from sine and cosine? So what are the main things that kind of jump out at you on? Like, how is tangent different? Number one is asymptotes, which affect the shape, right? We don't have that continuous curve because of those asymptotes. So asymptotes in the shape. What's the other big difference, I would say? Yeah, it changes that shape. Yeah, I think that's the other big difference. The period is pi instead of 2 pi. So we get one full of that curved shape between 0 and pi instead of normally it's between 0 and 2 pi before we get that one curve. So getting to all those basics, again, the principal axis can change. So normally that's 0, like we saw in our original graph, but that could change, and that's just where like it changes direction. So it starts going, and then it kind of changes direction a little bit at that principal axis. This, we just said, one of the big differences is the fact that the period has changed. So instead of the period equal 2 pi over b, the period equals pi over b. So that's different from sine and cosine. The amplitude is undefined because we keep going up and down, but it could affect the steepness. So if you end up having an A that's a big number like 2 or 3, more than 1, it's going to make it steeper. And if you have a number like 1/2 or 1/4, it's going to make it wider. You're not going to see that a lot though, but just in case that pops up, I wanted to mention it again. And then the negative tangent is our reflection. So like our normal tangent kind of makes this shape. So that's our normal tangent. So if we have the negative tangent, it's going to go like this. So it's going to curve the other way. And it's weird because it like looks like it's a reflection horizontally, but it's a reflection vertically, but there's the same, so it kind of looks weird. So we are just going to graph 2 of these, and then we are going to be done with the notes. But are there any questions or concerns before we start graphing a couple of examples? So our first example is we're going to graph the tangent of x plus pi over 2. Remember, if it's plus on the inside, it's moving it left or right. Normally we think pluses go right, but because it's on the inside, it's actually going to go to the left, pi over 2 units. Now, especially if I'm moving horizontally with these, left or right, I like to figure out where my asymptotes are first, and then draw in the graph after that. Now, I'm going to start, setting this up the same way I've been doing it. So all the notes so far, we've been going to 4 pi. So for consistency, we'll keep it to 4 pi. and then put all the other values in. So normally, very good. You guys ready? We start or not? Okay, so we still sketch that graph. Where is our asymptote normally? What? Pi over 2. Normally it's at pi over 2, but I'm going to the left pi over 2 units. So my asymptote will actually be at 0. Same thing, normally the next one would be at 3 pi over 2, but I'm moving over pi over 2 units, so the next one's at pi. So then the next one is pi later. The next one's pi later. So those are my asymptotes. So normally at pi over 2, which shifted over. And if you forget that, honestly, I would write this on your blue sheets because the asymptotes aren't really clear. So I would do like a little dotted line at pi over 2 and 3 pi over 2 just to help myself remember that. Because it's not, they don't draw the asymptotes in, right? Like, just if you draw those lines, that might help. So like the normal is at pi over 2, but I shifted it over. Now there's nothing being added afterwards, which means my principal axis is still at 0. So I'm gonna hit 0 halfway in between. So this halfway can kind of help you graph. So halfway in between these asymptotes is when I'm going to hit 0. So I'm going to hit 0 at all of these. And then I can kind of sketch my graph. I think mine got a little off, but you know, try and make them look the same. We are going to graph one more, but are there any questions or concerns? But you can still see the period is pi, not like we've got one full thing in pi, because that didn't change. It should all be about the same, because we didn't change the amplitude either. Okay, ready for the last one? So we're going to graph y equals tangent of 2x. And so this is b, remember, and so what this is going to be is it's going to be a stretch, and it's going to affect the period. So we'll take a look at that. I'm just going to get my graph set up. So if we recall, the period is pi over b. So b is 2, so my period is now pi over 2. So normally, my period would be pi, and the asymptote would be at pi over 2. You guys with me? But it gets squished into pi over 2 because it's a factor of 1/2. So I'm squishing it in which means my whole thing will happen between 0 and pi over 2. So my asymptote will be halfway in between that, which is technically at pi over 4. Because normally it's at pi and my asymptote's at pi over 2, so it got squished in, and that asymptote's halfway. So what's going to happen now, every section is pi over 2, there's going to be an asymptote down the middle. So the middle of this, we're going to have an asymptote. Middle of that, we're going to have another one. Because it's getting squished in, because that period is changing, smaller now. So then, my principal axis didn't change. So in between my asymptotes, halfway in between my asymptotes, that's where I'm going to hit 0. So I'm going to hit 0 at all of these marks, actually. I'm going to start with actually my first 2 asymptotes, just because that's my preference. I'm going to go back and through the beginning. So again, we're going through, drawing our shape here. Try to make it about the same. And I know I get a little wacky with my tangent. So then here, I kind of get confused sometimes, so that's why I like to start with like drawing one curve, because then I can see like, oh, that one's just going to go up. So that's it for the notes. Are there any questions or concerns about graphing tangent? Okay. Anyone still need it? So your practice assignment is just 1, 2, and 3. I do have more graph paper if you would like more graph paper. Try to fill up all the graphs that you've got, but I'll pass that out. I know I said this yesterday, but I know some of you were gone. I said expect a quiz by the end of the week. Is there a quiz on the schedule for today? So I bet you can use your logic skills to know what's going to happen tomorrow. So do your homework.